We all know wood has a quality to burn in air. When wood burns, we lose wood because it gets converted into some other species or kinds of matter like carbon dioxide, water vapor, and ash. So, if you want to observe this property of wood, you must be prepared to lose it because it gets converted into some other kinds of matter. Such a property is called a chemical property. But when you hold this piece of wood in your hand, you can feel its mass. To observe mass of this piece of wood, you don't have to convert it into some other substance. Such a property is called a physical property. So mass is a physical property, and we know we can measure mass. A physical property that can be measured is called a physical quantity. So mass is a physical quantity. But how do we measure mass? See, measurement is always a comparison. When we say a tree is 10 meters tall, we mean its height is equal to 10 times whatever length we are calling 1 meter. So we are comparing the height of the tree with the length that we call 1 meter. When we say the mass of a bag of oranges is 5 kilograms, that means it is 5 times whatever mass we are calling 1 kilogram. Here we are comparing the mass of this bag of oranges with whatever mass we are calling 1 kilogram. Okay, what is that mass that we are calling 1 kilogram? Initially we took the mass of 1 liter of water as 1 kilogram. Later, we made a small cylinder using an alloy of two metals, platinum and iridium, and took the mass of this particular cylinder as 1 kilogram until the year 2019. In 2019, the definition of a kilogram has changed again, and this cylinder is safely locked away in the suburbs of Paris in the International Bureau of Weights and Measures. Wherever you see 1 kg, understand that it represents a particular amount of mass present in the real world. It is a representation of matter present in the real world on paper. So it is more than a label. It represents the physical quantity called mass. Now let us say there is a bag of oranges that weighs 5 kilograms. So the mass of the bag of oranges is 5 kilograms, or 5 times whatever mass we are calling 1 kilogram. And 1 kilogram is the mass of that platinum iridium cylinder that we took as standard or reference to measure the physical quantity mass. Now when you multiply a physical quantity with a number, you will get the same physical quantity. So when you multiply 1 kilogram, that represents certain amount of the physical quantity called mass with a number, you will get mass again. That is why 5 kilograms is the mass of the bag. It is very important to understand this. Now let us move this term to the left hand side. Then on the left hand side, we will have mass of the bag of oranges over mass of the platinum iridium cylinder, and on the right hand side, we are left with just the number 5 with nothing beside it. Now this number 5 does not multiply any physical quantity. This is just a number. Therefore, this ratio no longer represents the physical quantity called mass. Then what is the meaning of this ratio? This ratio tells the number of times the bag of oranges is heavier than the platinum iridium cylinder that is taken as the reference. That is why this ratio is called relative mass of the bag. And relative mass, because it is a ratio between two masses, it is dimensionless. When you divide a physical quantity with the same physical quantity, you will always get a number, a dimensionless number. So, kindly observe the difference between relative mass and mass. Relative mass is the ratio between two masses, and it is a dimensionless number. It does not represent any physical quantity, whereas mass represents the physical quantity called mass, and it has a unit. A physical quantity cannot be without units. A number cannot have units. So, obviously, relative mass and mass are two different things, but they are numerically equal. The difference is very subtle, but it is very important. Do not use relative mass and mass interchangeably. They are not the same. I repeat, relative mass is a number and it is not a physical quantity. Mass is a physical quantity that is expressed in the units of mass. If the question is the number of times one is heavier than the platinum iridium cylinder, or the mass of a person relative to the platinum iridium cylinder, then the answer is always a dimensionless number. But if the question is what is your mass or weight, then it is a number expressed in the units of mass. So they are not the same question. So the answers would not be same either. Now, kilogram is the unit of mass in the International System of Units, that is the SI system. But United States is one of the three countries that do not use kilogram as the reference for mass. They still use the old imperial unit pound to measure masses. If you weigh the same bag of oranges in United States, its mass will be approximately 11 pounds. That is 11 times whatever we are calling 1 pound. And again, if you take this term to the left hand side, then we will have mass of the bag of oranges over mass of 1 lb, and it will be equal to 11. And there is nothing beside this 11. Again, this number is the ratio between these two masses, and again it is the mass of this bag of oranges relative to this reference called 1 pound. That is why it is called the relative mass of the bag. But the point to be noted here is the relative mass of the bag when compared to this pound is 11, but the relative mass of the same bag when compared to a kilogram is 5. So the relative mass of the bag has changed. Obviously, that is because the mass of the reference 1 kilogram is much higher than the mass of the reference 1 pound. Therefore, the value of the denominator here is less than the value of the denominator here for the same numerator. That is why the relative masses of the same bag are different when compared to a kilogram and a pound. So the relative mass obviously could change when the size of the reference changes. Whatever you have in the denominator is the reference. But the mass of the bag is always a constant. You cannot say the bag now weighs more in United States than elsewhere. The mass of the bag, the physical quantity mass of the bag is a constant. Now let us try to answer this interesting question. Imagine this fruit shop that sells identical apples and identical oranges. That means all the apples in this shop have the same mass. Likewise, all the oranges also have the same mass. My goal is to buy equal number of apples and oranges. Their counts don't matter. I don't mind if I buy 5 each, 50 each, 500 each, as long as their counts are equal. Obviously, you cannot buy them by count. If you could, then there is no riddle to be solved, right? You could just walk to the shop and ask for a dozen each, problem solved. But you can buy them by weight. You can ask for certain weights of apples and oranges. So, the goal is to buy equal number of apples and oranges by weight. How do we solve this problem? Actually, this is not at all a difficult question to answer if we are allowed to weigh an apple and an orange. Let us say the mass of an apple is 0.2 kilograms and the mass of an orange is 0.25 kilograms. Then obviously to buy one apple and one orange, we would ask for these weights of apples and oranges. To buy 2 apples and 2 oranges, because all apples are identical and all oranges are also identical, we would ask for these weights of apples and oranges. In general, if you want to buy n apples and n oranges, the weights we should buy are n times 0.2 kilograms of apples, n times 0.25 kilograms of oranges. What is the ratio between their weights in each case? In the first case, it is 0.2 to 0.25. These units get cancelled. In the second case also it is the same because these units get cancelled and these numbers also get cancelled. And in the general case also it is the same. So all these ratios are equal. Then what is the ratio between the mass of one apple and the mass of one orange? 0.2 kilograms to 0.25 kilograms. Again, these units get cancelled, so it is 0.2 to 0.25. So these ratios are all equal to the ratio between the mass of an apple and an orange. So if you buy equal number of apples and oranges, then the ratio between their weights is equal to the ratio between the mass of one apple and one orange. Then the converse also must be true, right? If the ratio between the weights of apples and oranges that we buy is equal to the ratio between the mass of one apple and one orange, then we are guaranteed to have an equal number of apples and oranges. Now what can we say about the number of apples and oranges in 4 kilograms of apples and 5 kilograms of oranges. First calculate the ratio between their weights. It is 4 to 5. Is this equal to the ratio between the mass of an apple and an orange? Let us see. It is 0.2 to 0.25. You multiply both with 20. It would be 0.2 times 20, 0.25 times 20. So this would be 2 times 2, 4, 2.52 times 2, 5. So this ratio is equal to this ratio. That means in these weights of apples and oranges, we will have an equal number of apples and oranges. Then what can you say about 2 kilograms of apples and 2.5 kilograms of oranges? The ratio is again 2 to 2.5. If you multiply both with 2, it would be 4 to 5, same as this ratio. So again, these weights of apples and oranges would have equal number of apples and oranges. See, we are no longer looking at the mass of an apple and the mass of an orange. We are only comparing the ratio between the weights that we buy with the ratio between the mass of one apple and the mass of one orange. If they are equal, then we are guaranteed to have equal number of apples and oranges. So all the information that we need to answer this question is just this ratio. If you know this ratio, you can answer this question. You don't need the mass of an apple and the mass of an orange. Now, how did we figure out the ratio between the mass of an apple and an orange? By weighing them using a kilogram weight as reference. What if this weight is not available? We can use a pound weight if it is available, and if you weigh them using this reference, their masses would be 0.44 lb and 0.55 lb respectively. Again, the ratio between their masses is 4 to 5. This is interesting. So the ratio between the mass of an apple and an orange is the same whether we weigh them in pounds or in kilograms. So because to answer this question, all we need is this ratio, we do not have to worry about the reference that is used to actually weigh them. I don't care whether they are originally weighed in pounds or kilograms, because all I need is this ratio, and this ratio is the same irrespective of the reference used to weigh them. So we can say that if the ratio between the weights of apples and oranges that we buy is equal to the ratio between the relative masses of an apple and an orange, then we will have equal number of apples and oranges, provided all apples are identical and all oranges are identical. In case if we are still wondering why I said relative masses here instead of masses, remember, to answer this question, all we need is this ratio, not their weights in pounds or kilograms or some other unit. And to figure out this ratio, all we need are the masses of an apple and an orange relative to some reference. All we need are these numbers. So this ratio does not depend on the reference used to weigh them. Of course, the relative mass of an apple would be different on these two references, but the ratio between the relative mass of an apple and an orange is the same. This does not depend on the reference used to weigh them. Therefore, to figure out this ratio, we don't have to worry about the reference used to weigh them. All we need are these numbers relative to some reference. That is why I said relative masses here instead of masses. Hope that helps. Now let us make this puzzle a little more interesting by saying that we neither have a pound weight or a kilogram weight to weigh them. But I still want to buy equal number of apples and oranges from this shop. See, to be able to buy equal number of apples and oranges, we need this ratio. Earlier, we figured out this ratio by using a pound weight or a kilogram weight. But now I have neither. Then how do we figure out this ratio? Also, let us expand this puzzle to other fruits. Say this shop also sells mangoes, pears, pineapples and grapes in addition to apples and oranges. And fruits of each type are identical. All apples are identical, all mangoes are identical and so on. And every time I go to this shop, I want to buy two types of fruits, apples and oranges, or apples and mangoes, or oranges and pears, or any other combination that is possible. But I want to buy them in equal numbers. Again, we don't worry about their counts. 5 each, 15 each, 23 each. Doesn't matter. Now, we already figured out a rule to be able to do this. If we know the ratio between their relative masses, then we know how to buy them in equal numbers. So, if you want to buy equal number of, say, mangoes and pears, all we need is the ratio between their relative masses measured using some reference. Say you want to buy equal number of oranges and mangoes, then you need the ratio between their relative masses. If you know that, you know how to buy them in equal numbers. But we do not have a reference now. We neither have a kilogram weight nor a pound weight to find their relative masses. Then how can we achieve what we wanted to do? Any ideas? See, to be able to buy equal number of fruits, we need these ratios. As we already proved, these ratios do not depend on the reference used to weigh them. So it does not matter whether the reference is a kilogram or a pound or even the mass of a grape. This ratio must be same. It is independent of the reference used to weigh them. So, if we could figure out the relative mass of a fruit of each type, then we are back in the game. And that's what we do. We compare the mass of an apple with the mass of a grape. Say you have to add 200 grapes to balance the mass of one apple, then the relative mass of an apple is 200. That is when compared to the mass of a grape. And say the relative mass of an orange when compared to the mass of a grape is 250. Then again the ratio is 4 to 5. It must be 4 to 5, otherwise this measurement is wrong. So because we do not have a kilogram or a pound, we took the mass of one grape as reference and we found that their relative masses are again the same. Now let us say, taking the mass of one grape as reference, We determined the relative mass of a fruit of each of these types. Say these are their relative masses. See, the relative mass of a grape is obviously 1 because the mass of one grape is taken as reference. You place one grape on one pan. To balance its mass on the other pan, we have to place only one grape. That is why its relative mass is 1. Now if I want to buy equal number of all these fruits, then what must be their quantities? Simple. If their quantities are in the ratio of their relative masses, then you are guaranteed to have equal number of fruits. You may not know what that number is, 5 each, 15 each or 53 each, but you are guaranteed to have equal number of fruits if their weights are in the ratio of their relative masses. And this is mole concept. And here is the summary of what we have learned. To buy equal number of fruits of different kinds, assuming fruits of each kind are identical, the ratio of the quantities of different kinds of fruits that we buy must be equal to the ratio of their relative masses. So if we buy 4 kilograms of apples and 5 kilograms of oranges, then these weights are in the ratio of 4 to 5, same as the ratio of their relative masses. Therefore, in this case, we will have an equal number of apples and oranges. Though these weights are in pounds, they are in the ratio of 4 to 5, same as the ratio of their relative masses. So, in this case also, we will have an equal number of apples and oranges, and same in this case. Now let us try to answer a few questions to consolidate our understanding. What must be the ratio of their weights if we want to buy twice as many apples as there are oranges? Now the ratio of their relative masses is 4 to 5. So if the quantities that we buy are also in this ratio, then we will have an equal number of apples and oranges. But we want to buy twice as many apples. So we have to multiply this n with 2. That means we have to multiply this 4 also with 2. So it would be 8 to 5. So to buy twice as many apples as there are oranges, then the quantities that you buy must be in the ratio of 8 to 5. The next question reads, what must be the ratio of their weights if we want to buy thrice as many oranges as there are apples? Again, the ratio of their relative masses is 4 to 5. So if the quantities are also in this ratio, then we would have an equal number of apples and oranges. But if we want to buy thrice as many oranges as there are apples, so we have to multiply this n with 3. Then we have to multiply this 5 also with 3. So it would be 4 to 3 times 5, that is 4 to 15. So if the quantities of apples and oranges that we buy are in this ratio, then we would have thrice as many oranges as there are apples. The next question reads, what must be the ratio of their weights to have equal number of apples and oranges? It must be equal to the ratio of their relative masses, 4 to 5. What about oranges and mangoes? What are their relative masses? 250 and 350. So the ratio is 250 to 350. I think that is 5 to 7. So if the quantities of oranges and mangoes that we buy are in this ratio, we will have equal number of oranges and mangoes. The next question reads, what is the ratio between the number of mangoes and the number of oranges in 5.5 pounds of oranges and 15.4 pounds of mangoes. Again, the ratio of their relative masses is 5 to 7. And if the given quantities are also in this ratio, then we would have an equal number of oranges and mangoes. But the given quantities are in the ratio of 5.5 to 15.4. If you divide both with 1.1, the ratio becomes 5 to 14, that is 5 to 2 times 7. So there is a multiplier of 2 before this 7. So we have to multiply this n also with 2. It becomes n to 2 times n, or 1 to 2. That is the ratio between the number of oranges and the number of mangoes. But we are asked for this ratio, so it would be 2 to 1. So there would be twice as many mangoes as there are oranges. And the next question reads, what is the ratio between the number of mangoes and apples in 7 tons of mangoes and 4 tons of apples? What are their relative masses? 200 and 350, right? Yes, so the ratio of their relative masses is 200 to 350. That is 4 to 7. And the ratio of the given quantities is also 4 to 7, same as this. So we will have an equal number of apples and mangoes. Now let us move on to the next topic and do a couple of questions on averages. Say we have 3 apples with different masses and we are asked to calculate the average mass of an apple. Obviously, we add up the 3 values that are given and divide that sum with the total number of values given to get the average mass of an apple. But the question is, what is the meaning of this average and this calculation? One way to understand this is, imagine you somehow added up these 3 apples into a big apple and then divided that apple into 3 identical apples. Then the mass each of that identical apples would have is what is the average mass of an apple. Now let us answer another question on averages. This time we have 8 apples each with a mass of 200 grams, 2 each with a mass of 180 grams, 1 with a mass of 172 grams. Again we are asked to calculate the average mass of an apple. Again we add up the 3 values given and divide that sum with the number of values given. So the answer again would be 184 grams. But is this answer correct? Let us see. What is the meaning of this average mass? This is the mass an apple would have if all these 11 apples are identical. So if you have 11 identical apples each with a mass of 184 grams, then the total mass of the 11 apples must be 24 grams. But let us see what the mass of these 11 apples actually is. We have 8 each with a mass of 200 grams, so their total mass is this. 2 each with a mass of 180 grams, so their total mass is this. 1 with a mass of 172 grams, so it is 172 grams. So the total mass of the 11 apples is 2132 grams. But based on this average, it must be 24 grams. So they are not matching. That means this average is wrong. But where did we go wrong? Remember how we determine averages. We imagine all these 11 apples are combined into a big apple and divide that big apple into 11 identical apples. Now what would be the total mass of that big imaginary apple? We added up 8 each with a mass of 200, 2 each with a mass of 180, 1 with a mass of 172. So this is the total mass of that imaginary apple that we divide into 11 identical apples. Then this would be the mass of each of those identical apples. And this is the correct answer. But what is the difference between this calculation and this calculation? See, in this calculation, we only summed up the 3 values given. We ignored the fact there are actually 8 apples with this mass, 2 apples with this mass. The number of times a particular value appears in a group of values is called its frequency or distribution. So 200 appears 8 times, 180 appears 2 times, 172 appears 1 time. So you have to multiply the value with its frequency or distribution and then sum up the terms and divide that total sum into equal parts. And an average calculated in this fashion is called weighted average. Remember, when you calculate average, do not ignore the distribution or frequency of the values given. Otherwise, your average would be wrong.